What's up, guys? Happy Monday. Hope you had a good weekend. This week, we're going to be dealing a lot with solving equations and specifically solving quadratic equations because that's the unit we're in, right? So, um, obviously, what makes an equation quadratic is this squared, right? Whenever the highest exponent that we see on a variable is 2, right? Then we know it's quadratic. So, let's start off with a really simple example, right? And we'll move on to more difficult ones in a minute. So today we're just dealing with one specific process of solving quadratics, and it's by square root. So um, if you're seeing this equation, x squared equals 36, I know to solve an equation, I need to get x by itself, right? And what's keeping x from being by itself? This exponent of 2. And how do we undo squaring? By taking the square root. But whatever I do to one side, I've got to do to the other. So the square root of x squared is x, right? Because the square root and the squared undo each other. And the square root of 36, you guys know it, it's 6. But we have to keep something in mind, and this is where it's going to be a little different than what you guys have done before. This equation has two answers. Not only does x equal 6, but x also equals negative 6. And I want you to think about that. Take 6. 6 squared equals 36, but take negative 6. Negative 6 squared also equals 36. So this equation has two answers. And the way we normally write this in shorthand, whenever it's the same number with opposite signs, we write it like this: x equals plus or minus, let me redo that, x equals plus or minus 6. Because positive 6 squared is 36 and negative 6 squared is 36. Let's try another example. So 2x squared equals 50. Similar to the last problem, but if you'll notice, we have a little something extra that we got to deal with. Not only do we have an x squared, but we have 2 times x squared, or 2x squared. So the first thing we got to do here is divide both sides by 2. Because I'm trying to get x by itself, right? So I'm going to start by getting rid of that times 2. 2 divided by 2 is 1. So I have 1x squared equals 50 divided by 2 is 25. And now we're dealing with one just like the problem before, right? I want to get x by itself. It's being squared. To get rid of the squared, I've got to take the square root of both sides because I know the square root of x squared is just x. And the square root of 25, just like before, both positive and negative 5 satisfy this equation. Because if you think about it, positive 5 squared equals 25, and negative 5 squared equals 25. So what I would encourage you to do to make sense of this, take positive 5, plug it back in up here, take negative 5, plug it back in up here, and see how both of those, when you plug it into the original equation, will get 50 equals 50, right? It'll give you a true statement either way. Let's move on. X squared minus 8 equals negative 4. So again, not only are we dealing with an x squared, but we're also dealing with another constant on the same side, right? So before we deal with that exponent, let's get all of our constants to one side. So how do I get rid of that minus 8? I got to add 8 to both sides. Because positive 8 and negative 8 make 0, right? Negative 8 plus 8 is 0. So I'm left with x squared. Negative 4 plus 8, that's positive 4. And now, if you notice, we're dealing with something very similar to the previous two examples, right? I got to get x by itself, right? It's got a squared with it to get rid of the exponent of 2, I've got to take the square root of both sides, right? Because the square root of x squared is x. The square root of 4 is positive and negative 2. Because again, positive 2 squared is 4, minus 8 is negative 4. Negative 2 squared is 4, minus 8 is still negative 4. That's why ours has 2 answers, positive and negative 2. Let's move on to an example that's a little bit different. Same process, a little bit different. So here I've got p minus 2 squared equals 16. So before, we were dealing with the variable being squared only. Now I want you to see this example. P minus 2, this entire binomial is being squared, not just the p. So before we can add 2 to both sides, right, because we're trying to get everything away from p, that minus 2 is kind of locked in here with the p because of that squared. So we've got to get rid of that squared first, and hopefully you're starting to see that to get rid of a exponent of 2, you got to take the square root of both sides. And the square root of something squared, well, these undo each other. So I'm left with just p minus 2 equals. Now, this is the part that's super easy to forget, especially at first. But whenever we're dealing with these quadratic equations, the square root of 16 is both positive and negative 4, right? Now, this looks a little funky. This looks a little weird. We don't normally see plus and minus on the same number in an equation. So some of y'all are probably thinking, what the heck do I do from here? Looks complicated. It's actually not too bad. We're going to split this up into 2 equations. So I have p minus 2 equals positive 4 and p minus 2 equals negative 4, because I know p minus 2 equals plus 4, positive 4, and negative 4, right? So we're going to split it up into 2 equations, one with the positive 4, one with the negative 4. And from here, these are 2 really easy equations for us to solve, 2 one-step equations. To get rid of this minus 2, I'm going to add 2 to both sides. And I'm left with minus 2 plus 2 is 0. So I have p equals 6. Got to do the same thing to this equation. Add 2 to both sides. Minus 2 plus 2 is 0. And I have p equals negative 2. So if you notice here, we didn't have a plus or minus situation in our answers. We had a positive 6 and a negative 2. We have 2 different answers here. P equals 6, P equals negative 2. Tomorrow's lesson, it's going to start making sense why we have 2 answers. And we're going to look graphically. We're going to look at quadratics graphed, right? The parabolas. And you're going to actually be able to visualize why these things have 2 answers or 2 solutions, right? And that'll start making more sense tomorrow. One last example for you, and this one looks very complicated, but we're going to follow the problem-solving strategies that we know, and you got this. So we got a lot going on this left side, right? I got a minus 27, I got a times 3, I got a plus 8, and I got a squared. So before I start dealing with this squared, right, I got to get everything away from p. I'm going to start by getting all of my constants to one side, right? The easiest thing to mess with at first is just to get rid of this minus 27. So the opposite of minus 27 is plus 27. I'm going to do that to both sides. And I have 3 times p plus 8 squared equals 27. Now from here, I'm close to being able to get this p plus 8 squared by itself. What's keeping that from being by itself is this times 3. So to get rid of this times 3 over here, I'm going to divide both sides by 3. Because 3 divided by 3 is 1. So I have 1 times p plus 8 squared, or just p plus 8 squared. 27 divided by 3 is 9, right? Now this looks like the example from before. I'm going to scroll down a little bit so we got some room to work. So p plus 8 squared equals 9. Trying to get p by itself. I can't mess with this plus 8 yet because this whole thing is being squared. That means I've got to take the square root of both sides in order to get rid of that exponent of 2. And when I do that, I have p plus 8 equals. Now here's the part you got to be really careful to remember. The square root of 9 in this case, right, when we're solving these quadratic equations, is positive and negative 3, right? So how do we handle this? Well, remember from the example before, we're going to split this up into 2 equations. P plus 8 equals 3, and p plus 8 equals negative 3, right? Now, solve both equations. Subtract 8 from both sides. For this left equation, I got p equals negative 5. And for this right equation, I have p equals negative 11. And that is how you solve quadratic equations using square roots. So go on Canvas, try out a couple of practice problems. Watching me do it's one thing, but trying it out for yourself is another. Don't worry about making mistakes. It's for effort, not accuracy. Just make sure you're spending time on each question, getting practice. Email me, send me a message on Remind, message on Canvas if you got any questions. Have a great Monday.